Hello everyone, this session I will be discussing angle between two lines in space. I hope you have understood the concept of straight line in three-dimensional geometry, the equation of straight line in symmetrical form, in scalar form as well as in vector form. Now, in vector form, there are some advantages to imagine the problem and to solve a problem quickly, which is included in your syllabus to study three-dimensional geometry. I mean, vector at our time also was there, three-dimensional geometry was also there, but we did not have the scope to imagine three-dimensional space and to deal problems in 3D with the help of vector. You have the advantage. So, before you do anything in 3D geometry, remember that if you can apply vector method, it will be of great help. Okay, let me start angle between two lines without wasting any time here now. So, let me start with the vector form of two lines. So, let two lines be r equal to a1 plus tb1 and r equal to a2 plus sb2. These t and s are scalars. I need not explain. A1 is a point on the first line. The first line is directed along the vector b1, that you know, this is L1. The second line directed along the vector b2. So, when the problem is to find the angle between two lines, don't you think that it is the angle between the two vectors b1 and b2? So, angle between L1 and L2 is the angle between B1 and B2 here. So, we are going to find the angle between the vectors B1 and B2. Assume they meet at the point O. This B1 and this is the direction of B2. We have produced, because a vector can be slid parallel to itself, theta be the angle. So, angle between L1 L2 is the angle between B1 and B2. We use the dot product formula. So, if we apply dot product here, that cos theta is going to be B1 dot B2, that divided by mod B1 into B2. You know the meaning of mod B1 and mod B2. Those two are moduli of two vectors B1 and B2. And now, if two lines are perpendicular, if L1 is perpendicular to L2, then what do you observe? Then theta equal to 90 degree. So, cos 90 is going to be 0, and this is nothing but B1 dot B2 by mod B1 multiplied by mod B2. So, if you simplify it, this is going to be B1 dot B2 equal to 0. So, if two lines are perpendicular, then angle between B1 and B2 is 90 degree and dot product will vanish. But if it is not, then we will be using the formula for finding theta here. Let us apply it in solving one problem here. Angle between the following pair of lines. I hope you can compare with the two forms already I have discussed. And here it is r equal to, this is A1, A1 is this part, it has no role to find the angle, and this is B1, r equal to A2, which part is A2? This one, and B2 is this part, I plus 2j plus k. So angle between the given lines be theta. Then cos theta equal to B1 dot B2 by mod B1 mod B2. Okay? Mod B1 mod B2, B1 vector, I told you this part is B1 vector and this part is B2 vector when straight line is given in vector form. So B1 dot B2 going to be 3i 2j 6k dot I plus 2j plus 2k, that divided by under root modulus of this 3 square 2 square 6 square multiplied by 1 square 2 square 2 square. So take the dot product, 3 plus 4 plus 12 by 7 into 3. So this is 19 by 21. So theta will be what? Cos inverse 19 by 21. Okay? So this way you can find the angle between two lines when it is given in vector form. Okay? They are not perpendicular because dot product is not 0. So, and if in your board calculator allowed, then you go by this for finding cos inverse 19 by 21. Otherwise, you leave your answer here. Now we'll find angle between two lines in scalar form. Scalar form, that symmetrical form is x minus x1 by a1, y minus y1 by b1, z minus z1 by c1. This is line 1. And line 2 is x minus x2 by a2, y minus y2 by b2, z minus z2 by c2. So first line is directed along the vector a1i b1 j c1k and second one a2i b2j c2k. Now as I told you earlier, this line given in symmetrical form means these are either direction ratios or direction cosines a1 b1 c1 a2 b2 c2. Question is, how do you understand whether given in terms of direction ratios or direction cosines? The method also already I have explained. A1 square, b1 square, c1 square, their sum is 1. They will be direction cosines. Otherwise, L1, L is proportional, direction cosines are proportional to what? Or you better you write direction ratios. So I told you that those direction ratios are proportional to direction cosines. This must be equal to L1 is to M1 is to N1 and A2 is to B2 is to C2 will be what? L2 is to M2 is to N2. Okay? So, if not given in terms of direction cosines, it doesn't matter. You just write L1 equal to A1 by under root sigma A1 square. You know it. Meaning sigma A1 square is A1 square, B1 square, C1 square. M1 is B1 by under root sigma N1 A1 square and N1 is C1 by under root sigma A1 square. L2 is what? A2 by under root sigma A2 square. M2 is B2 by N2 is C2 by under root. So, if you know direction cosines of two lines as L1, M1, N1, L2, M2, N2, then you know the angle. Cos theta in this case will be, what theta is the angle between them, L1, L2 m1 m2 plus n1 n2. And if lines are perpendicular, lines may be perpendicular, then what will happen? For perpendicular lines, theta will be pi by 2 and L1 L2 m1 m2 plus n1 n2 must be equal to 0. For parallel lines, what will happen? L1 by L2 will be m1 by m2, that is n1 by n2. Okay, this you know. Now, if we go by writing this L1 m1 n1 and L2 m2 n2 over there, cos theta can also be written in this form. Put the values of L1, L2, M1, M2, all these things over there. This is L1, L2. It means A1, A2 by under root sigma A1 square, sigma A2 square. B1, B2, same thing. So we can write this way. So here, in case of directional issues, if lines are so theta you can get by this formula, cos inverse this thing, sigma A1 A2 by under root sigma A1 square, sigma A2 square. For perpendicular lines, theta will be pi by 2. So 0 will be A1 A2 plus B1 B2 plus C1 C2. So this is going to be that A1 A2 plus B1 B2 plus C1 C2 equal to 0. This is for perpendicularity. And for parallel lines, what will be the conditions? For parallel lines, direction ratios will be proportional. A1 by A2 equal to, that is C1 by C2. Hope you have understood. So first thing, angle you find either by using this form, direction cosines, or by using this form. Perpendicularity and parallelism you decide this manner. Let us see one application here. Why have I taken this example, which is very confusing for you? Is it really confusing? No. Once you know these tricks, that is where to find the angle between two lines, I need to express the lines in the symmetrical form. But there is a break in the symmetrical form. And this part is also not like symmetrical form. Then what to do? Even this part. The method I told you earlier, how to convert this thing into symmetrical form. You multiply here inner and there by -1, here also -1, then it can be done. Okay, I am showing. You write this one as x minus 5 by -3. We rewrite. Rewriting the given equation, we get x minus 5 by -3, y plus 3 by -2, this z equal to 5 you deal this way, z minus 5 by 0. You will ask me why 0? Because direction cosine you are writing, no? That gamma may be 90 degree. So that cos gamma is 0. That's why you write this manner. That's why it is given separately. So we compare both these with z minus 5 by 0. The advantage is you cross multiply with 0 and this form is restored. Clear? So this is our first line. Second line, x minus 0 by 1. Here also multiply by minus 1, y minus 1 by minus 3, z minus 5 by 2. Now it's clear. You got direction issues because their sum of the squares is not 1. 9 plus 4, 13, and 1 plus 9 plus 4, 14. Their square root, sum of their squares is not 1. So they are not direction cosines. We go by direction ratios formula. So this part is going to be A1. Which part? This part will be A1. This is B1. This is C1. A2, B2 and C2. So we can write cos theta now. Cos theta will be what? A1, A2 plus B1, B2 plus C1, C2 by under root A1 square, B1 square, C1 square, A2 square, C2 square. Just put it there. So cos theta will be what? A1, A2 minus 3 into 1, B1, B2 minus 2 into minus 3 plus C1, C2 that divided by under root 9, 4, 0 and here 194. So minus 3 plus 6, 3 by, this will give us 3 by 13. If calculator not allowed, you will be writing theta the angle between two lines in the form cos inverse 3 by 13. It's okay, I think. I have taken one example which is not given in symmetrical form and you have to find the angle between these two lines. Problem of finding angle only. How to? Here we take 2 as common from inner and rear. Y plus 3 by minus 2, z minus 3 by 1, y plus 1 by 4, z minus 6 by 5. Okay? So this we write again x minus 5 by 1. This is expressed in what form now? It is in symmetrical form. You can go for calculating the angle between L1 and L2 by using formula state. Because remember, angle can be determined when lines are expressed in symmetrical form. Okay? So that angle between L1 and L2 be theta. Let theta be the angle. Cos theta will be what? A1, A2. 1 into 3 minus 1 into 4 1 into 5 by under root 9. This multiplied by 1 plus 1 plus 1. 8 minus 4 is 4. This is 5 root 2 root 6. So cos theta will be 4 by 5 root 12. Clear? So multiply inner and rear by root 12. It will be 5 into 12. Cancel the factor. Bring 2 outside. So theta going to be cos inverse 2 root 2 by 15. I am trying to show you examples which will give you the confidence to start sums from your book. textbook, any book, NCERT, that IIT JEE book, SNJ book, RDSM, or whatever. Okay? Now let us see another problem here. Find the value of P so that the lines are at right angle. See the form of the line given here. Symmetrical form not given. Again I have taken this example just to clarify that part. As soon as you see the problem of finding angle, please don't start that step. First you check whether it is given in symmetrical form or not. Then if it is, you go for finding angle. If it is not, change into symmetrical and then go ahead. So let me rewrite the first line, L1. L1 is what? Multiply by -1 here. The method I told you. Because symmetrical form is x minus x1 by a, y minus y1 by b, z minus z1 by c. Coefficient of x, y, z should be 1. Here it is 7. So divide inner and rear by 7. Or at one step you take common. Next step you divide by 7. Or x minus 1 by -3 Hope you have understood what are A1, B1, C1 here. This will be -3. This step is clear to you. This is equal to this. Okay, order triplet. They are comparable. Now for the second line, for L2, here again you take -7 common in the beginning. So it will be x minus 1 by 3p. Y minus 5 by 1. Take minus common from here. -1. -1 we have taken common. Therefore, x minus 1 by divided by 7. Y minus 5 by 1. It's okay. Now, for the second line, those A2, B2, C2 are known. -3p by 7, 1 and -5. Clear? Now, lines are given perpendicular and you have to get the value of P. How to? Because they are perpendicular, as L1 and L2 lines are perpendicular, therefore A1, A2, B1, B2, C1, C2 must be 0. So -3 minus 3p by 7 plus clear to you? Just A1, A2, B1, B2, C1, C2, 0. So this will give us 9p by 7, 2p by 7 equal to 10. Take it on the right side. I can see one mistake done by me here. This is plus actually. So this will be plus 2p by 7. So this implies 11p by 7 equal to 10. So p equal to 70 by 11. It's okay? Clear? Hope there is no problem in understanding these kind of problems which is given in your textbook. You can start. Let's see next type of problem. This is another very interesting sum. It is given. Determine the equation of line passing through 1, 2, minus 4 and perpendicular to the two lines. Lines are given in symmetrical form. two given lines are in symmetrical form. And a line can be perpendicular to two lines in 3D. The concept you have. They are neither parallel, they are not parallel, but they are coplanar. Two lines always coplanar. The third line you have to find which is perpendicular to these two lines and a point on the line given. How will you start? So we go by symmetrical form. We assume that let the line be what? 1 point form. X minus 1 by A, y minus 2 by B, z plus 4 by C. Okay? Hope you have understood. Symmetrical form here. This is the line whose equation you are going to find. It is perpendicular to this line. It is perpendicular to this one also. So line 1 perpendicular to line 2. Since 1 and 2 are perpendicular, so what condition do you get? A1, A2, B1, B2, C1 into C2 equal to 0. So 3A, 16B, this is number 4. 1 and 3 also perpendicular. Are also perpendicular. So what condition do you get there? It will be 3A, 8B minus 5C 0. Two lines are perpendicular. Given this line, first one perpendicular to this as well as this. Now the problem is to solve the values of A, B, C. But we will solve it by the method of cross multiplication which you have done before, I think, when class 10 level. Isn't it? If you don't remember it, I will remind you to get it quickly. Okay? Let me show you. For this one, first line you write A, B, C. No, that 3 minus 16 and 7. Second line coefficients. I am writing coefficients only. And in method of cross multiplication, we need to write these two once more. 3 minus 16 and this is 3, 8. Okay? Now what? You put A here, above it, B here, just one step forward. Okay? This is downward arrow. This is upward. Downward, upward. Now what? A, B, C we can find by the method of cross multiplication. A by this into this and downward arrow, it will be positive. That is 80. Minus this into this, upward, that's why negative. Clear? B by 21 plus 15, C by 24 plus 48. Hope you have understood. Because downward arrow positive, the upward arrow negative. I mean product when you consider 3 to 8, it is positive, but 3 into minus 16 minus 48 will be plus. So this is going to be A by 24, B by 36, C by 72. So A by 2, B by 3, C by 6. ABC ratios you have got, and that is enough. Why? Why have I told this? Because once you get ABC, then you can compare. You compare with M, a scalar. Then A going to be what? A equal to 2M, B equal to 3M, 6M. So from 1, what do you get? X minus 1 by 2M, Y minus 2 by 3M, Z plus 4 by, you cancel M. This is the beauty of mathematics. Okay? This is invented by human being as the best subject of study, that you must believe. Y minus 2 by 3, this is the line which is perpendicular to the given lines. Clear? Idea is clear? You could have done by the use of vector method also. Convert this one into vector method and then do it. No problem. Method is similar. There you can take the help of cross product. I am showing you. This one. I have taken the vector form also so that you understand properly. Then you start sums from your textbook on your own. You need not rely on anyone in this world. You are the boss of your own subject of study. Take the help. This manner, people from outside just telling you, many books are there, you study and do it yourself. So long you cannot do yourself, no study material is enough for you. Okay? Only understanding. Try to understand and then apply the concept. Clear? Do it here. For this one again, but I will be solving it with the help of vector method. Then you compare. I will not say that I have the preference for vector method only or on scalar form only. When you are solving the sum, that you will decide. So you start this manner. Let the line be what? Let the line be r equal to 2I minus t plus 3k plus t into b. B means what? B means that B vector AI plus Bj but are we going for scalar form? No. So this is just for explanation. I'll be writing only vector B over there. That is enough because we will do it by vector method. Now this B is perpendicular to these two vectors. Which two? First line along this, I am taking longer time just for your understanding. Second line along 2j plus 2k. So this is like B1 vector and this is your B2 vector. They meet at this point, imagine. Now vector B is, as B is perpendicular to B1 and B2, therefore B is along B1 cross B2, isn't it? Cross product, you have done. If a vector perpendicular to two vectors, it will be perpendicular to the plane containing them. It is along their cross product. This is done in cross product. So B is along B1. You just find B1 cross B2. B1 cross B2 is what? that I, J, K. You are all very good in cross product. 1, 2, 2, I, then minus 4, minus 2, minus J, 4 minus 1, plus K into 4 plus 2. It's okay? Understood? Now it is minus 6I, isn't it? So you got B1 cos B2. This B vector along this and T is scalar over there. So B vector will be what? B vector will be some scalar. Say I am taking M into minus 6I minus 3J plus 6K. Put the value of B over there. Where? Here. So required equation going to be what? R equal to 2I 3K plus T into M. Both are scalars. Will you keep this form? Even if you assume that they are scalars, your textbook answer may not match. Why? Because we can take another factor common over there. So R going to be 2I plus minus 3MT into 2I plus J. Okay, so this is going to be 2I plus S into 2I. Understood? I have taken S equal to a scalar. Okay, so I have every right to replace minus 3MT by another scalar, and this is the required equation. Understood? I hope finding angle between two lines is not difficult for you. Just wait for another beautiful sum. Prove that the lines are perpendicular if A dash plus CC dash plus 1 equal to 0. Think, most of you are ready to do it with me. Try if you can do it faster than me. At that time. Why? Because first job is to express this one in scalar form, and that you must understand. So we take B on the left side, AY. So this gives us x minus b by a equal to y by 1. You are in class 12. Hope this is not a problem for you. Now take this part, this part. This part is what? Z minus d equal to cy. Okay? So now y by 1 can be compared with this one, and we get the line in symmetrical form. Therefore, the required equation is clear? Understood? The first line I got this form, which is known as symmetrical form. Direction ratios are A1 and C. Go for second one. Is there any difference? No. Just A dash, B dash, C dash, D dash written in place of ABC. So if you try the same manner, these two lines can be, this is L1. This can be written as x minus b dash by a dash, y minus 0 by 1. Clear? This is your L2. Direction ratios are a dash, 1 and C. Now lines are perpendicular. Since L1 perpendicular to L2, line 1 perpendicular to line 2. What do you get? A1, A2, A into A1, 1 into 1, therefore, this is A dashed. So this implies A dashed plus C dashed plus 1 equal to 0. Clear? Hope understood by you? Okay? A brilliant sum given here, pair of lines whose direction cosines are given by these are perpendicular. This kind of sum actually shown to you before. Okay? In vector or in 3D part 1, I don't remember, or part 2, you must go through it. Why have I taken again? Because this particular kind of sum is being asked in JEE. Your board also it is there. I don't know whether they are going to ask this year or not, but you must learn it properly. And the method matters. See the way I am solving here. Alternative method you must try if it is convenient for you. Just to answer it, to find the angle, they are perpendicular. Two lines and two conditions. Is it enough? Yes, because additional condition is there that sum of the squares of the direction cosines equal to 1. That we know. Okay? So let me go by this method, eliminating L from number 1 and number 2. From 1, L is what? Clear? From 2, L into 3m minus 4n, or Cm clear? Take minus 1 common from here, minus 1 from here. So this is minus 6m square, 8mn this mn part is getting cancelled. So what do you get? So m square is 2n square. Therefore, now we apply the second method here, that is m by n whole square equal to 2. So m by n whole square plus 0 into m by n is a quadratic of m by n. So two values of m by n expected for two lines. So what kind of roots you expect here for this equation? Roots are m1 by n1, m2 by n2. Am I clear? Quadratic equation. Roots are of this form. So sum of the roots, you know. Sum is m1 by n1. Let me write both. Which one helps? That will decide 0, and product equal to minus 2. Therefore, m1 by m2 by So two lines, their direction cosines two parts, m1, m2, n1, n2 related by this relation. I have to relate another one. Another one means I have to relate L and M or L and N also. You understand what I say? So we'll try to make another quadratic equation here. What equation? That I am eliminating, now I am eliminating, say, n from here. N from first is what? This divided by 3. N from second one, from 1. You got, now from 2. 3lm equal to n into 4l minus m. Clear? So I got n from two equations, I will be comparing. L plus 2m by 3, okay? So cross multiply here. This is going to be L plus 2m into m minus 4l, 3lm into 3. I have taken minus common from here also and then multiplied. Clear? Hope you have understood. So this will give us lm 4l square minus 8 lm equal to 9 lm. Clear? So this will give us 4l square 17 minus, that is 16 lm equal to 0. Okay, this is going to be quadratic equation of L by m here. Divide by m square plus, so we get 2 into L by m whole square 8 L by m. Okay, so what are the roots of this equation? Roots be L1 by m1 and L2 by m2. So product of roots what? L1 by m1, L2 by m2 equal to minus half, and you get L1 L2 by 1, m1 m2 by minus 2. I have taken a bigger problem here, but this will help you to tackle this kind of sum. In one previous episode I have explained this kind of sums in details, and I did the longest sum here, isn't it? So you can try all sums now. Must report, must tell me whether you are able to do all the sums from your textbook on your own. This one matters. Okay? So from 1 and 2, what do you get? L1 L2 by 1, m1 m2 by minus 2, n1 n2 by 1. We are waiting for this beautiful relation. We got it. Now compare them equal to lambda. Because equality we can, so L1 L2 plus m1 m2 plus n1 n2 is what? 1 into lambda minus 2 into lambda. This is 0. So L1 L2 m1 m2, this implies lines are perpendicular. Listen, angle between two lines and 3D straight lines so far I have discussed, I think enough for you to understand from a person in this world to understand basic concept of 3D. Once you understand the basic concept, you are done. This concept is important. Believe me, you will be able to solve all the sums from your book. If you cannot do it, send me a private comment. I'll try to help you without any other transaction. This is my aim, to tell you 3D concept without any transaction amount in this world. Okay? Hope you will try and you will get success to solve all the sums in 3D. Thank you. See you again.